In this video, we'll talk about how to convert a set of simultaneous linear equations into matrix equation form. We'll also talk about how to convert back. Now, for our set of simultaneous linear equations, let's have 3x1 plus 2x2 plus 3x3 equals 4. We'll also have 2x1 minus x2 plus x3 equals 2. And we'll have x1 plus 5x2 plus 0x3 equals 1. Now, I've just made these up on the spot and I have no idea what the solution is, but we're just working here on converting to matrix form. Now, when we're converting to matrix form, all we're doing is we're going to take all of the coefficients we see here and put them in, there and put them into the matrix A, and then we're going to take the right-hand side values and put them into a vector B. So, A equals, it must be a 3 by 3 matrix. We have 3, 2, 3, 2 minus 1, 1, 1, 5, 0, just from all of those coefficients. X are all of our x values. So sometimes they've got different names. We might be talking about x, y, and z. We might be talking about x1, x2, x3, or maybe even a, b, c. So it's just important to make sure we remember what we're talking about. And we're talking about a column vector as well. So here it's x1, x2, x3. As for our b, we can read it straight away from the right-hand side of the equations above in red there. And our b is equal to 4, 2, 1. Like that. Okay, so now that we've defined our A, B, and C, let's have a look at what the actual matrix form looks like. The actual matrix form would be A times our vector x is equal to B, our right-hand side vector. And that's how we convert to matrix form. Now let's have a look at how we would convert back from matrix form. Let's say we have the matrix A equals 2, 1, 1, 3. And we have the vector B equals 4, 2. And x is equal to x, y. So it's important to note there is a difference between vector x with the underline and the scalar x with no underline. And these are our unknowns. And our matrix form here is AX equals B. If we're going to convert back to a set of simultaneous linear equations, all we're going to do is we're going to take the coefficients from A, multiply them out by our vector x, and then equals to our right-hand side vector B. That means we have 2x plus, here we go, 1y equals 4 from that first row here. So first row, first row, first row. Now we're looking at our second row here. And we have 1 when I'm talking about second row here, I shouldn't be circling, and same as when I was doing first row, I shouldn't be circling a value in the x vector. So before, when I circled the x scalar, that was incorrect, and when I just circled the y scalar, that's incorrect as well. So here we're working with 1x plus 3y equals 2. And that's it. That's all we need to do to be able to convert from a set of matrix equations to a set of simultaneous linear equations. I hope that you'll be able to convert in either direction.